We're talking about examining the solutions of quadratic equations. The goals, one, to find the kinds of solutions that quadratic equations yield, the kinds of numbers, in other words, you get. Are they real numbers? Are they complex numbers? That sort of thing. Goal number two, we want to build quadratic equations from given solutions. In other words, we're going to go backwards. I'm going to give you a couple of solutions, and you're going to give me a quadratic equation that would have those numbers as solutions. Okay, I need to remind you guys how we categorize numbers. So what numbers did you learn about first when you were a kid? 1, 2, 3, 4, right? So we have a name for those numbers. 1, 2, 3, 4. What do we call those? They are real. They are whole. They are the counting numbers, right? Or the natural numbers. So their smallest categorization is the counting numbers. And then I think most people learn about 0 before they learn about negative numbers, right? So if you throw 0 in there, and so these blobs represent set containment, or they represent sets, right? That innermost blob is the set of counting numbers. This outer blob containing the set of counting numbers also contains the number 0. That's supposed to be a 0 right there. And that would be, if you take both of them together, both blobs together, that's the set of whole numbers. And then in reality, you probably learn about a few fractions before you learn about negative numbers, right? Like you learn about the number 1/2 really early on. My son is 6 and he knows what 1/2 is. He doesn't know a whole lot about negative numbers though. But set-wise, containment-wise, you learn about the integers next. So the integers contain the whole numbers, which contain the counting numbers, but also the opposites of those numbers. So like -1, -2, -3, and so on and so forth. So these are called integers. This outer blob is called integers, and it contains the whole numbers and the counting numbers. And then what do you learn about? Eventually, you learn about fractions at some point, right? The fractions, all the fractions you can form with integer, numerator, and denominator except 0. You can't have 0 in the denominator. Those are called rational numbers. So rational numbers are fractions, which is where, when we just got done playing with rational functions, right? Rational expressions, that's where the name comes from. You see rational, think fractions. So the rational numbers are just all the fractions you can form with like an integer in the numerator and an integer in the denominator. So like 7/2, -3/5, and of course it includes decimals and repeating decimals like 1/3, which is 0.3 repeated. And those are called the rationals, okay? If there's the rationals, then what else is there? The irrationals. So the irrationals are totally separate, actually. I have to draw a totally separate blob. It's actually just as big, if not bigger, than this blob, but I'm not going to draw it that big. So the irrational, can you think of it, the most popular irrational number in the world? If you had to pick one? What do you like to eat on the 4th of July or Thanksgiving? Pie. Yeah. But also the square root of 2. The square root of any non-perfect square is irrational. So what does it really mean? Well, you can't write it as a fraction with an integer, numerator, denominator. It can't be done. So it's irrational as opposed to rational. Because in that first set of blobs, every number can be written as one integer over another. So like the number -1, or how about the number -2 can be written as -2 over 1. So it's a rational number. Can't do it with pi. I mean, you could write pi over 1, but pi, that doesn't make pi a rational number. So the integer and denominator have to both be integers. The numerator, rather, and denominator have to both be integers for it to be a rational number. So those are just a couple of examples. So what are the real numbers? Just combine them together, and you got the real numbers. Combine them together, and you've got the real numbers. So the real numbers are just the union of the rationals and the irrationals. And then what other number set have you learned about in this class? The complex numbers. So the complex numbers the complex numbers contain the real numbers. Every real number is a complex number. Like you could write the number 7 halves as 7 halves plus 0 times I. But the complex numbers are also non-real numbers like 1 plus 2i. That's a fully complex number. And you can't get it inside the other sets. So the snail represents all the numbers you're probably ever going to hear about. This whole bit was just to draw the snail. But if it helps you remember it, that even better, right?